Good morning, my students.
Today we are continuing our discussion of the last year Keam papers. Now today we selected questions from our unit 3, which includes gravitation, solids, properties of solids, fluids, then thermal properties. Now we can start with the very first question is there on the boards. See the question there. If a body is taken from surface of earth, it loses its weight by 20% at the height. It loses 20% weight mean weight become 80%. What? That was there on the surface of the earth. It loses 20%. So on the surface of the earth, then at a height h is equal to 0.8. Here is equal to 1 mg. Here is equal to 0.8 mg. Now we will see the expression for that height. Now weight is equal to mg. Here the weight reduces because g reduces. Weight reduces by 20% means g also reduces. Or g value now reduced from g to 0.8 g. Now at the height h, the formula g dash is given by g into r squared by r plus h whole square. You remember the formula? G dash is equal to g into r squared by r plus h whole square for considerable height. Now this is the relation where g dash is the accelerator due to gravity at this point. That is 0.8 g. 0.8 g means 0.8 g is equal to g into r squared by r plus h whole square. You cancel out. 0.8 means 4 by 5. Is equal to r squared by r plus h whole square. Take root on both sides. 2 by root 5 is equal to r by r plus h. Cross multiply. 2r plus 2h equal to root 5r. Therefore, h is equal to root 5r minus 2r r into root 5 by 2 minus 1. So that is the height at which this happens. And go through the option and see what the option there. Option is equal to, here you can see that here that is the options. You know, when higher altitude, when we go higher altitude, accelerator due to gravity decreases. Similarly, when you go into the air, accelerator due to gravity decreases and formula relevant. That is there with you. Formula minimum requirement. So go to the next question. Question read like this: if a planet orbits the sun in the elliptical orbit, the quantity associated with the planet that remain constant are. What are the things that constant there? You can see then total energy always constant. Total energy conservation is there. Then by second law, Kepler, in aerial velocity dA by dt equal to L by 2m. dA by dt formula, aerial velocity dA by dt L by 2m. The constant means this is a constant in which m is already constant. Therefore, angular momentum is also constant. And therefore, angular momentum and the total energy is constant. And see what is the option there. Total energy and angular momentum conservation, it is tau. So the option is tau. Shall go to then our next question. For flow of incompressible liquids through a pipe, the venturimeter is used to measure. Principle of venturimeter is there very well there in your NCERT book. And there we can say that we can calculate the velocity of flow first. Now knowing velocity of flow, you can calculate the volume flux. Here the option, if you go, pressure, liquid, volume of flow, rate of flow, that can be done using this, using venturimeter. Speed of flow. First of all, we have to calculate speed of flow. Then we have to calculate the volume flux. Volume flowing out AV means. First of all, we have to calculate V, for which we are using venturimeter. So the primary option is equal to C. Volume flow, that can be done. But what we are calculating in vectorimeter, we are calculating the velocity. And therefore, the correct option is equal to speed of flow. So, option is C. Next question. The quantity of heat. The quantity of heat conducted through a metal rod kept at the ends 100 degrees centigrade and 120 degrees centigrade is 5 joules per second. So, what is the temperature difference that is applied across the rod? 20. Whatever may be the temperature, here is 120 and here 100. The difference delta theta is 20. Now, heat conducted per second through this under this situation is equal to 5 joule per second. It is given. Now, what is the question? If the ends are kept to 200 and 220, 200 and 220 mean here 220 and this is 200. Still the difference remains the same. Delta theta remains the same. Heat conducted per second formula per second is given by Ka. Theta 1 minus theta 2, that is delta theta. By delta x or L. Here, it is the same, A is the same, delta x is the same. Delta theta is also the same. The heat conducted per second, the first case as well as second case are the same. Heat conducted per second. But come to the question. Heat conducted per second is the same. But the question is, the quantity of heat conducted in 10 seconds. In 1 second, it is 5. It is given that 5 joule per second. In 1 second. Therefore, in 10 seconds, 5 into 10. So, the answer is equal to 5 into 10 is equal to 50. So, go through this and we can see the option is equal to 11. Heat conductor depend on the temperature difference, not the temperature. Temperature difference between across the rods. So, the option is equal to 11. So, go to our next question. The escape speed of moon when compared with the escape speed of Earth is approximately. Knowledge question. Speaking. You know, the escape velocity from surface of Earth is above 11. And the escape velocity from moon surface is about 2.4 something. Therefore, simply the ratio 1.1 by 2.4. The value is near around 5. Then the question is the approximately, that term is there. And therefore, it is 11.2 by 2.4. The value is near around 5. So, it is 5 times smaller. Next question. There we must know the numerical value rather than the formula, numerical value of escape velocity from Earth and their own moon. We can go to our next question. The force of gravity is the nature of gravity force. You know, gravity force is a conservative force field. In our study, the two conservative forces we generally meet is electrostatic force and gravitational force. The gravitational force is a conservative force in which the work done do not depend on path, depend only on initial and final. Also, around the path net work done is equal to 0. These are some of the conditions you studied for conservative force, which is applicable in the case of gravitational force. So, the option is a conservative force. Option is equal to 11. Next question. The thermal velocity of a small steel ball falling through a viscous medium, and option you go. Depend many parameters. Out of this, the dependence is on the radius. We have to think about the radius. Question is the terminal velocity, not viscous force, terminal velocity. The expression for terminal velocity attained by a body when fall through a viscous medium is equal to Badan rho minus sigma into G by it. This is our expression. in which our dependence on R directly there, so V proportional to square of the radius. Formula must be there with you. So comparing, we get from the expression, we can get V proportional R square. So the option is directly proportional to square of the radius of the ball. So option is equal to C. Shall go to our next question. 8th question. The stress required to produce a fractional compression of 1.5 percentage, fractional delta V by V into 100, that is given. Fractional compression 1.5 percentage in a liquid having a bulk modulus. So we have to calculate the stress. And what is given? Strain is given and also the bulk modulus. Basic expression by Hooke's law. Bulk modulus is given by volume stress delta P by volume strain delta V by V. Of course, minus sign. They are not bothering about minus sign. And here the question is what is pressure? The stress required now. So stress is given by B into delta V by V. Stress is given by B into delta V by V. The bulk modulus is given to you. That is equal to 0.9 into 10 raised to 9 into delta V by V in percentage 1.5 by 100 by 100. Now get the answer, multiply and get the answer. On doing that, we get the answer. The value is found to be dark. This is on multiplication 9 into 1.5. Simple multiplication. This is equal to 10 raised to 9, cancel out 10 raised to 7. And therefore the value is equal to 1.35 into 10 raised to 7. That is our option. Direct substitution in the formula. The modulus of velocity is given by stress by strain, here a bulk modulus, and therefore B is equal to delta P by delta V by V. Okay. Go to our next question. When heat is applied to a gas in isochoric process, isochoric being volume same, and therefore there is no change in volume. If there is no change in volume, work done is zero in isochoric process, we know. Then the question is, for what heat supplied is used? By first law of thermodynamics, delta Q is equal to delta U plus delta W. Since it is isochoric, no change in volume, therefore delta W is equal to P dV equal to 0. Both, there is no change in volume. So this is 0. Therefore delta Q is delta U. So under heat given to it, used for increase in internal energy. Internal energy measure of temperature. So increase in internal energy and increase in temperature. So that option is there. C. Internal energy and volume, internal energy are only internal energy and temperature. That type is. Internal energy increase means there must be definitely change in temperature. And therefore this is the correct option. തെറ്റിക്കാനായിട്ട് ഇവിടെ ആൾ എടുക്കേണ്ടത് ഇന്റർനെറ്റ് ഓൺലി എന്നോ കാണിച്ച് ചെറുപ്പ് പോയിരിക്കും. അതെന്താ കാണിക്കണമെന്നാണ്. എന്താ കാണിക്കണമെന്ന് വെച്ചാൽ നിങ്ങളൊരു ക്വസ്റ്റ്യൻ കാണുമ്പോൾ ഓപ്ഷൻ നോക്കും. ഓപ്ഷനിൽ മോസ്റ്റ് കറക്റ്റ് ഓപ്ഷൻ യു ഹാവ് ടു സെലക്ട്. ഇന്റർനെറ്റ് കറക്റ്റ് but the most correct option internal energy and temperature. That is why it is given the weightage. Yes. Go to the next question. One gram of ice at 0 degree centigrade is converted into water by supplying a heat of 418.72 joule. The quantity of heat that is used to increase temperature of the water from 0 degree centigrade. You know, 1 gram of water, and we are given latent heat of fusion of ice. The value is given as 3.35 into, here that is 10 raised to 5 per kilogram. Then I want to get what is per gram by 10 raised to 3. It's equal to cancel out 10 raised to 2 is equal to 3.35 into 10 raised to 2 is equal to 335 joule. 335 joule per gram. That is the latent heat per gram. Change 1 gram ice in 1 joule. That is okay. So that is given to you. In our problem, what is that? You gave how much heat? 418.72. Out of that 418.72, it is given that you gave this much. 418.72. This much heat is used for just for phase change, ice to water. The remaining heat, if any, used for rise in temperature. During phase, then there is no change in temperature. And how much energy is used for change of state? Minus 335.72, 83.72. 83.72 amount of heat is used for increase in temperature. So question is that he used to increase in temperature 83.72. So option is this one. ഇനി വേണമെങ്കിൽ അടുത്ത ചോദ്യം അവർക്ക് ചോദിക്കാമല്ലോ. അതിൽ എന്താ ചോദിക്കാവുന്നത്? What is the resultant temperature? MC delta theta. MC delta theta, use that is equal to this much heat. അവിടെ സി എഴുതുമ്പോൾ ജൂളിൽ എഴുതണം മാത്രം. Then get the final temperature. If they ask, ചോദിച്ചിട്ടില്ല. Go to our next question. The height above the surface of the earth at which acceleration due to gravity become half that on the surface of the earth. Earth the problem, other going to repeat it again. At what height? There, at what height acceleration due to gravity become 0.8 g. Here, acceleration due to gravity become half, that is g by 2. Same formula, same approach. And what is the answer? You know, at a height, g dash is given by g into r squared by r plus h whole squared. G dash is equal to g by 2. G into r squared by r plus h whole squared. You will cancel out. Take the root and cross multiply. R plus h is equal to root 2r, which is equal to r into root 2 minus 1 is equal to 0.414 r. R is equal to 6,400 kilometers. That numerical value can be calculated. So this is our answer. Now going through options, that answer is not there. And therefore the question was deleted during the last year. But the correct option is equal to this one, but here there is no option. And therefore it is deleted. It's okay. Next question. A particle 100 gram mass is projected vertically up with the kinetic energy 20 joule. ഒരു ബോഡി 20 ജൂൾ എനർജി കൊടുത്ത് പ്രൊജക്ട് ചെയ്തു. മാക്സിമം ഹൈറ്റ് റീച്ച്ഡ് ബൈ ദ പാർട്ടിക്കിൾ ഈസ് നെഗ്ലക്റ്റിംഗ് എയർ റെസിസ്റ്റൻസ് dissipate non-conservative forces are not there, and there is no part of this energy is utilized to overcome that. അല്ലെങ്കിൽ നോൺ കൺസർവേറ്റീവ് ഫോഴ്സുകളായിട്ട് വർക്ക് ചെയ്തിട്ടില്ല. പിന്നെ ഇപ്പോൾ ഒരു കൺസർവേറ്റീവ് ഫോഴ്സ് ഫീൽഡിൽ അപ്പോൾ എന്ത് സംഭവിച്ചിട്ടുണ്ടോ? ഗ്രാവിറ്റി ഫീൽഡില്ല. ഈ കൈനറ്റിക് എനർജി മുഴുവൻ പൊട്ടൻഷ്യൽ എനർജി ആയിട്ട് മാറിയിട്ടുണ്ടോ? ആൻഡ് ഹൗ മച്ച് ചെയ്ത എനർജി യു ഗിവ് 20 ജൂൾ, കൈനറ്റിക് എനർജിക്ക് 1 equal to potential energy at height h, mgh. Mass of the particle is 100. So 1 into 10 raised to minus 3 or 100 into g 10 into h equal to 0.1 into 10 into h is equal to 20. From this h can be calculated. H is found to be 20 meters. The body will rise up to a height 20 meters. Simply conservative force field. Kinetic energy become final potential energy. Equate and get the answer. It's okay. Next question. Question is, a ball is projected in still air. With respect to the ball, the streamlines appeared as shown in figure. The streamline is given to you. Now, wherever there is crowding of streamlines, velocity increases. Wherever there is less crowding, velocity decreases. That is the fact. That is how the streamlines are marked. And if you look here, you can say at 1, through unit area, the crowding is less. And over here, velocity V1 is less. Whereas here, number of flux lines through unit area is more, or crowding is there. Therefore, velocity here V2 is large. From very representation, from very figure, you can get that information. If the speed of air passing through the region 1 and 2, for region 1 and 2 mean here and here. Here velocity is more. Then by Bernoulli's principle, you know that wherever velocity increases, pressure decreases. So here P2 is less. P2 is larger. P2 is less. Here velocity is less, therefore P1 is large. P1 is large, P2 is less. P1 is large, P1 is less. P2 is large, P2 is less. That is enough. And see what is the correct option. 11. P1 less than P2 and P1 greater than P2 by Bernoulli's principle. Next question. The radius of two soap bubbles are respectively 2 meter and 3 meter, 2 centimeter and 3 centimeter. And the ratio of the excess pressure inside the soap bubble. In the case of a bubble, excess of pressure inside the bubble is gone by 4s by r. Because bubble has got 2 free surface. If it were a drop, it is equal to s by r. Only 1 free surface. Here 2 free surface, 4s by r. So P proportional to 1 by r. So P1 by P2 equal to R2 by R. P1 by P2 is equal to R2 by R1. Radius is given 2 and 3. There was the excess of pressure ratio is equal to 3 by 2. 3 is to 2. So it's equal to 3 is to 2. 3 by 2. So option is equal to box. Excess of pressure formula must be there. Next. The elastic energy stored. The elastic energy stored per unit volume in a stretched wire. Young's modulus material of the wire, S is the stress. So in terms of stress and Y, you have to represent elastic energy per unit volume or energy density. Energy density of a stretched string. You know the relation. 1/2 stress into strain. Second one, half stress into strain is replaced. Or stress is replaced. If stress is replaced, half Y into strain, Y into strain square. Or stress into stress by Y, half stress squared by Y. So our answer is half stress squared by Y. Because the answer asked about, the answer required the relation between S and Y. Or it must the result must contain S and Y. Stress and Y. So this is the expression S squared by Y. S squared by Y. This is the option is C. The expression ആണ് ചോദിച്ചിട്ട് ഇനി സ്ട്രെസ്സും സ്ട്രെയിനും y ആയിരുന്നെങ്കിൽ ഫോർമുല half into y into strain square. This is the way. Go through and select the correct options. Okay. Next question. The value of escape velocity V of a planet depends on. And you see, the value of escape velocity V of a planet or a given planet depend on. Now, escape velocity formula root of 2 Gm by R. Now here we can say escape velocity depend on mass and the radius of the planet. Mass and radius. The relation is there, mass of thrown, direction of projection of the body, angle of projection only on the mass of the planet. ഈ ആൻസേഴ്സ് കാണാനില്ല. പിന്നുള്ളത് mass, density and radius. Here as per this equation, it will depend on mass of the planet and radius. But one more term is the density. Now in terms of density, we write what is the expression? Equal to root of 2 G 4 by 3 pi R cube into density by R. So this will cancel out. There you can say it depends on radius and density. Mass is not there. അങ്ങനെ നോക്കുമ്പോൾ ഇതിനകത്ത് പ്രോബബിൾ ആൻസർ ആയിട്ട് നമുക്ക് പറയാൻ പറ്റും. Most correct answer is equal to it depends on mass and radius. There is no need of including density. Since density is also involved, then mass term is not there as per this equation. But that is there, and therefore the most probable equation is equal to that. കുറച്ച് ambiguity അതിനകത്ത് ഇല്ല എന്ന് ഞാൻ പറയുന്നില്ല, പക്ഷേ അതിനകത്ത് നമുക്ക് ഒരു മോസ്റ്റ് പ്രോബബിൾ ആൻസർ ആണ്. അപ്പോൾ ഒന്ന് നോക്കും മാസ് ആൻഡ് റേഡിയസ് മോസ്റ്റ് കറക്റ്റ്, അല്ലെ ഡെൻസിറ്റി ആൻഡ് റേഡിയസ് ഓക്കെ. But mass, massum, density, radius. Then that is right. Shall go to our next question. The slope of the graph plotted between the square of the time period, t square, and the cube of the mean distance from the sun. That is semi-major axis. Okay. Now you know what the time period equation. Time period in a center field force is equal to pi r raised to 3 by 2 by g, or t square is equal to 4 pi square by gm. Now here we are going to draw the graph connecting the variable and function. Function is t square. Function is t square. Variable is r cube. So this is equal to y is equal to this is y and this is x, and therefore y is equal to mx, and therefore slope is equal to m. Comparing slope is equal to by 4 pi square by gm. So the slope of that graph is given by 4 pi square by gm. 4 pi square by gm. So option is equal to E. Shall go to our next question. If n small identical liquid drops, each having thermal velocity v merge together, then thermal velocity of the bigger drop. Now, here we are collecting information from surface tension also. There you studied many number of droplets combined to form a large one. N number of droplets combined to form a large one. Have radius small r. From a large one radius r. R is equal to n raised to 1 by 3 small r. Relation is there. From Bowling observation, we can say the radius of the large drop is equal to n raised to 1 by 3 r, where n is the number of droplets combined, and r is the radius of each small droplet. Next, here the question is thermal velocity. Thermal velocity we did earlier. Thermal velocity proportional square of the radius. 2 by 9 r square formula you already wrote down. We did one problem there. So we propose to ask her. This relation is known to us. Then when n number combine, the terminal velocity V dash proportional to r square. That is proportional to n raised to 1 by 3 small r whole squared. That is proportional n raised to 2 by 3 r square. Dividing P dash is equal to n raised to 2 by 3b. P dash is equal to n raised to 2 by 3b. Dividing, we get the answer. So the answer is equal to. Next. A fluid has got a fluid has streamline flow through a horizontal pipe of variable cross section area. Then, what happens when a liquid flow through a pipe having an uneven cross section under streamline condition? Coupling equation of continuity as well as Bernoulli's principle. From equation of continuity, you know wherever area cross section is large, velocity is small. AV is a constant, that is equation of continuity. Area cross section is large, velocity is small. By Bernoulli's principle, wherever velocity is small, pressure is large. Coupling these two information, this is by equation of continuity and this is by Bernoulli's principle. Coupling these two, you got wherever area increases, velocity decreases, pressure increases. Wherever area decreases, velocity increases, pressure decreases. Now this is the result. But if you go through that options, there is no correct option. അതിനകത്തൊന്നും നമുക്ക് സെലക്ട് ചെയ്യാവുന്ന ഓപ്ഷൻ അതിനകത്തൊന്നുമില്ല. നോക്കുക, വെലോസിറ്റി മിനിമം അറ്റ് ദി നാരോ, velocity minimum at the narrow തെറ്റ്. Velocity and pressure both are maximum at the widest point. Velocity maximum തെറ്റ്. If velocity and pressure both minimum at the narrowest point, velocity minimum തെറ്റ്. Velocity is maximum at the narrowest point but pressure is maximum തെറ്റ്. Velocity is maximum at the narrow point. That is true. Pressure is maximum at the or we can say that its velocity is maximum at the narrowest point. Area of correction is small, velocity is large. Velocity is maximum at the narrowest point and pressure is maximum at the widest point. Wherever area cross section is large, pressure is large. Also, therefore, we can say that similar horizontal variable cross section, then this statement is almost correct. If velocity is maximum at the narrowest point, area cross section is small as velocity is large. Statement is ശരി. ഇനി അടുത്ത ഭാഗം, pressure is maximum, pressure is large, where area widest part, area cross section is large. Therefore, that statement is also correct. Therefore, most correct options will talk there. Next. Once again, അങ്ങനെ തന്നെയല്ലേ പറഞ്ഞത്, ഡോഗ് വെലോസിറ്റി മാക്സിമം അറ്റ് ദി നാരോ പോയിന്റ് ശരിയാണ്. ഏരിയ കുറഞ്ഞു കൊടുത്ത് വെലോസിറ്റി കൂടുതൽ അല്ലേ, ഇവിടെ എഴുതിയിട്ട് ഏരിയ കുറഞ്ഞു വെലോസിറ്റി കൂടി. ഇനി പ്രഷർ ഇസ് മാക്സിമം അറ്റ് വൈഡസ്റ്റ് പോയിന്റ്, ഏരിയ കൂടി കൊടുത്ത് വെലോസിറ്റി കുറഞ്ഞു, പ്രഷർ കൂടുതൽ. Pressure is maximum at the widest point. That's also true. And therefore, the most correction is equal to dog. അടുത്ത ചോദ്യത്തിലേക്ക്. A metal rod of length 1 meter at 20 degrees centigrade is made up of material of coefficient of linear expansion 2 into 10 raised to minus 4 per degree centigrade. The temperature at which the length increases by 1 millimeter. At what temperature is length incremented by 1 millimeter? You know, when a rod is heated, its length increases. And increase in length given by the formula delta L, called L alpha delta theta. Delta L is equal to L alpha delta theta. Here delta theta is as increasing temperature. So delta theta, the increase in temperature is given by delta L by L alpha. Delta L required 1 millimeter. 1 into 10 raised to minus 3 meter, delta L. Length of the rod is given 1 meter. Alpha, curvilinear expansion is given into 2 into 10 raised to minus 1. 2 into 10 raised to minus 1. Simplify, get the value of this value on simplification. We can get delta. What is delta? This is 100. 10 raised to 2 by 50. Delta theta is equal to 50. Increase in temperature is 50 degrees centigrade. Question is not increase in temperature. Question is the temperature at which length increase, temperature at which its initial temperature was 20 degree. When heated through further 50 degree, that means altogether temperature is 70 degree. So 50 plus 20 to 70 degree. So the answer is 70 degree. It is heated through 50 degrees, so that final temperature becomes 70 degree. So the option is 70. Adum Sadhikya. On calculation, what you got 50, that is increase in temperature. Question is not increase in temperature. Next question. The ends of a metallic rod. The ends of a metallic rod are at a temperature T1 and T2, and the rate of flow of heat through is Q joule per second. If all the dimensions of the rod are halved, keeping the end temperature constant, the new rate of flow of heat. Write down the formula we did earlier. Write down the formula for Q. Heat conducted per second through a rod is given by K. Theta 1 minus theta 2. Now, in second case, what happened? All physical dimensions reduced. So that what is the heat conducted? Q dash is equal to K. When physical dimension of the rod change, halved mean radius halved. Radius halved mean A dash become pi r squared. A dash become pi r by 2 whole squared equal to A by 4. So K A by 4. Temperature difference remains the same. Length halved L by 2. Length also halved. Now you can say that 2 goes up, cancel out, and that becomes Q by 2. So Q dash is gone by Q by 2. So the answer is dog. There what we require is the form, remember the relevant formula. Enough. Next question. The rate of emission of a perfect black body at a temperature 27 degree. Whenever you know Stefan's law, the temperature is not in degree, but in absolute scale. There were 27 degrees centigrade with 300 Kelvin. Our body is at 300 Kelvin. And by Stefan's law, heat conducted per second through unit area proportional to fourth power of absolute temperature. Therefore, in the first case, Q proportional to 27 mean 300 whole raised to 4. The rate of modulus is E1, so that is equal to Q1 or E1. If the temperature of the body raised to 627 degrees centigrade, mean plus 273, 900 Kelvin. The rate of emission is E2. We can write what is E2. E2 is equal proportional to 900 whole raised to 4. Question number 1 and question number 2. Then what is they ask? E1 by E2 divide. E1 by E2 is equal to 1 by 3 is equal to 1 by 81. So the question answer is that much. So 1 by 81. So options play. They are verifying whether you remember step 1 step. And also the temperature they represent there in the expression is not degree centigrade but in Kelvin. Go to our next question. A block of mass m is kept. Block of mass m is kept on the floor of a lift at the center. The acceleration with the lift should descend so that blocks exert a force mg/4 on the floor of the lift. This is the problem we did in the last class. Again we are doing. A block of mass m is kept on the floor. Acceleration with the lift should descend. So, when a body accelerates down, tension, that is the action given on the floor is given by mg minus mv. And it is given that exert a force of mg/4, but T is mg/4. Therefore, ma is equal to mg minus T is equal to mg minus mg/4 is equal to 3/4 mg. Therefore, A is equal to 3/4 g. So, it must accelerate down with an acceleration 3/4 g. Option is available. We shall go to our next question. If the acceleration due to gravity on the surface of a planet is 2.5 times that of Earth, and radius 10 times that of Earth, then the ratio of the escape velocity on the surface of the planet to that of the Earth. Therefore, what we have to do? We have to write down the formula of escape velocity in terms of the relevant terms given to you. The physical parameters given to you. What are the radius and acceleration due to gravity? So, from surface of Earth, the escape speed is given by V is given by root of 2rg. And this is for Earth. The escape velocity from Earth. In another planet, escape velocity, V escape of planet is equal to root of 2r planet into g planet. Now what is ours? The accelerating due to gravity 10 times, then the ratio of the escape velocity surface of the planet to Earth. So it's equal to equation number 1. This is equation number 2. Question asked is 2 by 1. Gives V escape from planet by V escape from Earth is equal to root of Rp by Re into Gp by Ge. The ratio, planet ratio, radius ratio is given. And again, acceleration due to gravity, the surface of the planet is 2.5 times that on Earth. The Gp by G is 2.5. What about radius? Radius ratio is given to 10 times of that of Earth. This is 10. So the answer is equal to 1. So option is equal to 5:1. The boiler ratio is one more thing you have to remember. Order must be same. If you have order, 1:5 answer may be there. Which ratio they are asking? Put a planet by Earth. If it is Earth by planet, reverse ratio will obtain. So very careful which order they give. While you substitute, also remember the substitution must be in proper order. Otherwise, you will arrive at a wrong result. Definitely, that wrong result will be there on the option. We will at once mark and we will lose the mark. We will mark the option that you got. But ultimately, what is going to happen is that you may lose mark. So be careful. Come to our next question. The time period of revolution. The time period of revolution of a planet around Sun in an elliptical orbit and semi-major axis. Kepler law, T square proportional to A cube. T square proportional to A cube directly in. And Kepler law, T square where A is the semi-major axis, T square proportional to A cube. So that is our answer. So option is C. Go to our next question. In an incompressible liquid flow, mass conservation leads to AV rho. Mass flux AV rho is a constant. And this, if rho is also a constant, AV is a constant, which is the equation of continuity. And therefore we can say that in compressible liquid, the mass conservation leads to equation of continuity. The AV is a constant, or AV rho is a constant. The mass flux is conserved, volume flux is conserved, and that is the equation of continuity. Next question. The maximum velocity. The maximum velocity of fluid in a tube for which the flow remains streamlined is called. What is the name of that? You know, when velocity of flow increases, the body will maintain streamline up to a particular speed. And that is what is called our critical velocity. Below which it will undergo streamline motion. Above which it will undertake what is called turbulent motion. Tap open streamline. Wide open turbulent. Now there is a particular speed up to which that is maintained, streamline is maintained. Above which a turbulent begin is called our critical speed, and expression name of that critical speed box. And Reynolds number concept, you know that critical speed. This is the expression. Reynolds number, coefficient of viscosity, density, radius of the tube. With the critical speed formula. But here they are asking, simply write down the formula. What is the formula for this? I'm sorry, name of that velocity called critical velocity. Above which there will be streamline, below which there will be streamline, above which there will be turbulent. Come to our next question. The quantum linear expansion of aluminum as solid given to you 2.5 into 10 raised to minus 5. That is alpha L is given to you. Alpha L is a Rayleigh coefficient, alpha V is asked. Now, for a solid, isotropic solid, alpha V is equal to 3 alpha L. Alpha S is equal to 2 alpha L. These are the relations that. Now here alpha V is asked 3 into alpha M. So our answer is 3 into 2.5 into 10 raised to minus 5. Oh, 7.5. 7.5 into 10 raised to minus 5. Option is C. The option is C. Next. Linear expansion. And two spheres of radii. when two spheres of radii r and r by 2 are brought in contact, the gravitational force of attraction between them is proportional to. Not fully clear, or there is a lack of clarity. Now, what in the problem says, two spheres, well, this is a sphere of radius r, and this is the sphere of radius r by 2, put in contact. Now, what is the gravitational force between the depend on r now? Nothing is said about the density by which these are made, and therefore mass of this one and that one supposed to be a constant. Given mass for this one and this one, since densities are not given, because mass is given by volume into density. Here density statement is not there. It is simply given. If we go to when two spheres of radius r and r by 2 are brought in contact, gravitational attraction between them. We are going to say 3 marks. This is mass m1 and that is mass m2. So this is mass m1 and this is mass m2, separated by a distance r plus 3 by 2. R plus r by 2 is equal to 3 by 2 r. So this is the separation between them. Then, what is the force? Force is given by G, m1, m2, mass of this body fixed by 3 by 2r whole square. Therefore, we can say that r f proportional to 1 by r square. If it is said that density of both the spheres also is a constant, then mass need not be a constant that vary with the density of this body and that body. And therefore, you have to write down in terms of density. Then what will be the expression? F is equal to G, m1 is equal to 4 by 3 pi r cube rho. m2 is given by 4 by 3 pi r by 2 whole cube rho by 3 by 2 r whole square. If this is what is the stated, that is mean both the spheres are made of same material or density of both the material are same, then I have to write down the formula like this. In that case, you can say this is r raised to 6, here r square, therefore f proportional to r raised to 4. In this case, now you go to the option, both are there. Here there is r raised to 4 and this is r raised to minus 2. Which we have to take. There, better option mean they didn't say anything about the density. Therefore, mass is first body and second body. Or the first body remains same, second body remains same. And the separation between the center of that mass, only we have to consider that as 3 by 2 r, square of it. Therefore, proportional to r raised to minus 2. So, option is equal. If in the problem they are made of material with the same density, then the option would have B. But it is not so here, because nothing is said about the density. That is fine. Okay? Next question. The gravitational potential energy of a system of two bodies, each of mass m and the distance r between them is G the gravitational constant and small g the acceleration due to gravity. The gravitational potential energy, interaction potential energy, two bodies, masses m, distance r. What is the mutual gravitational force, potential energy between them? What's the formula? Gravitational potential energy between two masses is minus g m1 m2 by r minus g m squared by r. Since the masses are identical. So it's equal to minus g m squared by r. Minus g m squared by r. Acceleration due to gravity and nothing to do with the acceleration. The option is there, therefore option is called box. Shall go to our next question. Which of the following has maximum Young's modulus? Again, knowledge question. aluminum, copper, brass, steel, and iron rod. Out of this, most Young's modulus is highest power. Out of this, highest power steel. So observation. It is next. Energy stored in a soap bubble of diameter 4 centimeters nearly. Energy stored mean energy surface potential energy of a liquid surface. Potential or surface energy. Surface energy per unit area into area. That is the total energy possessed by that bubble. Since it is a soap bubble, it has got two free surfaces. And each free surface per unit area possesses surface energy, whose value numerically equal to surface tension. Surface energy, that is the potential energy per unit area of a free surface of a liquid. Numerical value same as surface tension. Then what is the total energy? Total free surface into surface tension. A bubble has got two free surfaces inside and outside. Therefore, what is the total free surface of a bubble? Total free surface of a bubble is equal to 2 into 4 pi r squared. If it were a drop, it has got only one free surface. Then the free surface is 4 pi r squared. It is equal to, here it is 2 into 4 pi r squared. Into surface tension. This is the energy. The total energy possessed by that body is going by, bubble is going by 2 into 4 pi r squared into S. It's equal to 2 into 4, 8 into 3.14 into. What is the radius of the bubble? Radius of diameter is given 4. The radius is equal to 2 centimeter. 2 into 10 raised to minus 2 whole squared. The surface tension 0.07. This is the total energy possessed by the body, that bubble. Now, this on multiplication, the value is about 7. This value. That on simplification option is found to be C. Next one. When two different liquids of same mass, but at two different temperatures, 27 and 47, are mixed together. The resultant temperature of the mixture is 35 degrees centigrade. Then ratio of the viscosity opacity. Equal mass. Suppose this is the first liquid. Viscosity opacity is C1, mass is M. At first liquid at the temperature 27 degree. This is the second liquid, same mass. Another liquid viscosity opacity different, and the temperature is 47 degree. They are mixed. So the resultant temperature, you got an equilibrium mixture. The resultant temperature is 35. Now question is, what is the ratio C1 by C2? There you can see that this body on mixing with this one, you got the resultant temperature, so that it gain heat. And temperature increases, therefore it gain heat energy. And the energy gained by this body is going to MC delta theta. So M C1 delta theta, 35 minus 27. Is the heat gained. Whereas this on mixing loses heat and heat lost by energy conservation. Heat lost and heat gained are the same. So we are equating. Heat gained by this liquid is equal to heat lost by this liquid equal to M C2, this is C1. And falling temperature 47 minus 34. M multiple. So C1 into here 8 equal to C2 into here is 12. So C1 by C2 is equal to 12 by 8, 3 by 2, 1.5. Equal to 3 by 2. So the answer is there. Is equal to 3 by 2. Go to our next question, 34. Two perfectly black bodies are at temperature T and 2T ratio between the wavelength corresponds to maximum energy emission. And that the idea we came from Wien displacement law. There it says that the maximum wavelength emitted by a black body, lambda m, depend on its absolute temperature by the relation lambda m proportional 1 by T, or lambda m into T is a constant. This is Wien displacement law. Lambda m into T is a constant. Now, here, two body lambda, first case, lambda 1 proportional 1 by T, lambda 2 proportional 1 by 2T. Then the question is the ratio between the wavelength, lambda 1 by lambda 2. Question number 1, this is question number 2. Lambda 1 by lambda 2 gives you 2T by T. 2:1, so option is clear. And here we apply the Wien displacement law, where lambda proportional 1 by T. Next question. When water is heated from 0 to 8 degree, its volume, there we begin to fact the anomalous property of water. Water when heated from 0 degree, here volume and here temperature in degrees centigrade starting from 0. When heated, volume decreases first up to 4 degree. Thereafter increases. So then first decreases and attain minimum volume at 4 degree, and thereafter increase with increase of temperature. This is the anomalous property of water, and therefore the answer first decreases up to 4 degree, then increases. So option is equal to A. So okay, we came up to 35 questions there. So this finishes our unit 3. Tomorrow we again meet with the unit 4. So thank you.